Hey, Ryan here with Solar Power on Demand. I'm at an off-grid system that I built for a customer, and the customer's concerned that the batteries might need replacing due to low capacity. So I'm going to show you how to check their capacity using a load tester and do that while the system's operating safely. So we have our load tester here from Harbor Freight, 100 amp, and it works with 6 or 12 volt batteries. You're going to connect black to negative, red to positive across a single 12 volt battery. And as you can see right here, it tells you the system's charging because it's reading about 14 volts. So it knows that the battery alone wouldn't be supplying that voltage. So we could hit the short circuit load tester all we want, and it's just going to heat up a lot and not really give us an accurate reading of the battery's capacity, because the solar panels are actively working and charging the battery bank, and they're putting in 44 amps. So when we hit that short circuit load tester, it's telling us, hey, the battery is really strong, but that's not really accurate because it's actually just taking current from the solar panels. So to get an accurate reading of the battery's capacity, we're going to turn our solar power off. And we'll also want to turn any loads off as well. So we're going to turn off the loads, turn off the inverter, and now the battery bank is isolated. It doesn't have current going in or out, so we can get an accurate measurement of the battery's capacity. So with the battery isolated, no current going in or out, we can see it's charged to just below 13 volts. So it's fully charged. And now we're going to hit this 100 amp short circuit load tester. And we see it's good. It's staying in the green at that 1000 cold cranking amp level. So that's good for that first one. Now there's 12 of them, and so we're gonna have to go through and check each one. But that's the process. Once you're done checking the batteries, then you can go ahead and turn on your loads, turn on your inverter and solar inputs. And here's an example of a battery that's weak and needs replacing. So even though the rest of the batteries are charged fully and are at least 12 volts, this one didn't get above 11 volts. And then when we apply that short circuit load, watch the voltage drop. So clearly this one is bad.